Hello class, this video is about break-even analysis. We will focus on an example from your textbook, the mobile telephone plans, and go through this procedure step by step. What is the break-even point? In simple words, when we talk about break-even points, we're looking for an amount where the costs are equal to the income, and passing this certain point, you will start being profitable. So it's a boundary, a milestone, where you can claim that at least I will not lose money. Similar to this, a break-even analysis, in break-even analysis, we are interested in comparing two alternatives to see which one is better for us. Under what conditions this plan excels the other one. So let's review the mobile telephone plans problem. It's from, as I mentioned, it's from your textbook. Imagine you are willing to get a plan for your cell phone. You have narrowed down the plans from the available ones to just two of them. Let's name them as Plan A and Plan B. Both of them cover unlimited local calls in the evenings and on weekends. Also, they cover unlimited text, picture, and video messages. So these properties is not going to affect our decisions, because the situation is the same for both of the plans. However, the plans differ in price and the number of Monday to Friday daytime local calls. Plan A, as you can see in the table, costs $35 per month, and it includes 200 minutes per month of local calls. Plan B costs $42. And also, it consists of 1,000 local minutes. In both of the plans, for an extra minute of calls, either local or long distance, you should pay 50 cents per minute. Also, as you can see again in the table, you can change the local call into anywhere call by adding extra $10 per month in both of the plans. So a situation gets a little bit complicated, and to simplify the problem, we can define 4 types of plans based on Plan A and Plan B. Let's name them as Plan A1, A2, B1, and B2. Plan A1 is just local calls. So each plan is divided into 2 sub-plans. In one of them, it's only local. In the second one, it's anywhere. It is also local and the long distance one. Plan A1 is just local calls with initial cost of $35 and a limit of 200 minutes. Plan A2, it takes advantage of adding long distance calls by accepting a cost of $10. So, and the same things for Plan B. You can divide it into sub-plans. To match our plans with the names of the textbook, we have named them as mentioned in the last column. So Plan P1 is the same as A1, P3 is the same as A2, and P2 is the same as B1, and P4 the same as B2. So this is just for matching our names with the ones available in the textbook. Now we are willing to formulate a problem based on the total local call minutes as well as the total long distance minutes of call. For this purpose, I introduced 2 parameters, A as minutes of local calls and B as the minutes of long distance calls. Because we are dealing with 200 and 1,000 minutes, we should divide our area into different intervals based on these two numbers. A, well, it can be less than or equal to 200, for example, or it can be greater than 200. So plan A, what was plan A? In plan A, as you can see in the table, extra minutes for both of the local calls and long distance calls will be charged, and the limit is 200. So if A is less than or equal to 200, there is no extra local call minutes, and each minute of the long distance will be charged 50 cents. If A is greater than 200, let's say, for example, 250, the difference between A and 200, which is 50 here, represents the extra local call minutes, and each extra minute will be charged 50 cents. Now we can combine these two equations, and the only difference between them lies in the 50 cents multiplied by A minus 200. In this situation, we can use the max function to put these two parts together. Pay attention to the highlighted text for more clarification. And having set these explanations, we obtain the final formula for the cost of plan 1 based on my parameters, which are A and B. All right, now I have something in my hand. I have the cost function for plan 1. The procedure for plan 2 or plan B1, well, is the same as plan 1. And finally, we get the cost function of the plan 2 based on A and B, as you can see. In plans P3 and P4, we have the limit for the summation of local and long distance call. Because the limit is based on both of them, therefore the extra minutes will be based on both of them as well. So in plan 3, if A plus B is less than or equal to 200, which means the total minutes of talking anywhere, the cost equals to $45 because we are dealing or we are not violating the limits. I mean, we are not violating the limit of 200. If we violate this limit, the extra cost of 50 cents for contacting anywhere will be added to the cost function. Now, based on these explanations, we can get the final cost for plan 3 based on A and B. So very simple. For plan 4, the procedure is the same as the plan 3. Now I built the cost function of all of the plans. I can compare them. I can compare plan 1 with plan 2. I can compare plan 1 with plan 3, plan 1 with plan 4, plan 2 with plan 3, and so on. Let's compare plan 1 with plan 2. If we're talking about break-even analysis, you're willing to find out under what conditions one plan excels the other one. And because we are dealing with costs, a better plan will result in a lower amount of cost. So let's see under what condition plan 1 excels plan 2, or in other words, the cost of plan 1 is less than plan 2. Please pay attention to the steps of the calculation. Very simple, and I have provided the procedure step by step. And please try to do it yourself. And if you feel that it's still weak, make numerical examples. Replace A and B with different numbers and see what is the relationship here. Now, if the maximum of a minus 200 and 0 is equal to or less than 14, plus the maximum of a minus 1000 and 0, plan 1 will be a better option for me. So I'm comparing two different values. One is related to cost of plan 1, and the second one is the cost for plan 2. If the cost, which is the left-hand side for plan 1, is less than the cost for plan 2, which is on the right side of the inequality, I will choose plan 1. So here, the first thing we want to do is to get rid of that max function. To do so, we have to divide the region into different intervals. My values, as you can see, there is no sign of b in the formula. So I will divide my region based on a only. A can be less than or equal to 200. It can be more than 1000, or it can stand somewhere between these two values. I mean, between 200 and 1000. If a is less than or equal to 200, it is definitely less than 1000 as well. Again, make examples for more understanding of the situation. In this case, a minus 200 is a negative number, also a minus 1000. What is the maximum of a negative number and 0? It is 0. And by replacing the associated values, we have 0 less than or equal to 14, which is a true statement. So as far as the assumption is true, I mean as far as a is less than or equal to 200, plan 1 will be our priority. This is the first case. And what happens if a is greater than or equal to 1000? This is the second case we're talking about. Following the same procedure, we get to the contradiction. Why? Because 800 is definitely greater than 14. Our result is not correct. So based on this calculation, we get to a contradiction. If a is greater than or equal to 1000, then plan 1 will not be a better option for me. So plan 2 here is a better option for me, not plan 1.